In the last video, we were expressing the volume of a solid generated by rotating some region R about a axis, well, about a line that is not the coordinated axis. In the last video, we will we left three problems. So we have the region generated, well, the region enclosed by x equals 4, y equals e to the x, y equals 1. We will rotate this about x equals minus 4. The other is the region enclosed by y equals minus 1, x equals 2, y equals x square x minus 1, about y equals minus 1. And the last one is the region enclosed by y equals sine x, the x-axis, and that is to the left of the line x equals pi over 2. I suppose that now you feel free of continue the video, and so just write your answer and next continue to see if we have the same result. Alright, so now we have the enclosed area of x equals 4, 4 e to the x, and y equals minus 1 is this area. We will rotate this around x equals minus 4, x equals 4. Let me put it as 4 because I already drew it like that. So this will be the solid that we will generate, more or less, something like this. So our cross sections or the discs will be something like this. So the radius would be the distance here between the line x equals 4, that it will be all this distance, and the distance of the graph. The distance of the graph is this. So if we subtract this to this, yeah, am I doing it right? Yeah. If we subtract all this, well, we subtract this from all this, we will have only this distance. So we are subtracting the function from 4. Now the function, we need to put it in terms of x. We have y equals e to the x, so this is x will be equals to the natural logarithm of y. So the radius r would be 4 minus natural logarithm of y. The area would be this square times pi. The volume would be this times delta y or dy, and the defined integral from the one is the intersection of the graph y equals x, y equals e to the x, and the line x equals 4, so would be in e to the 4. So that's our upper limit, e to the 4, and the lower limit, that is this, is y equals 1. We are enclosing in that area. So it is the defined integral from y equals 1 to e to the 4 of 4 minus natural logarithm of y all square times pi dy. Next is the region enclosed by y equals minus 1, x equals 2. Oh, here I forgot to put it. Sorry. X equals 2 and y equals x squared minus 1. So x equals 2 will be in something like here. Wait. Something like that. So we are taking all this area. This area enclosed by x equals 2, the function, and y equals minus 1. So it's all this area. The because we are rotating it around y equals minus 1, we would have something like this would be our volume or our solid. So now the discs will go like this. The radius of the disc is, you know, the distance between y equals minus 1 and the function. So in this case we can subtract the y equals minus 1 to this. That in this case, because we are subtracting a negative value, we will be adding it, because the value of y in the function is just this, but we need to add the minus 1 in order to have all these radius. So the radius r is equal to x squared minus 1 minus minus 1, so it's x squared. The area will be this square times pi, so area is x to the 4th pi. The volume will be this times delta x, the volume of each disc, and now the volume of our solid will be pi times the integration of x to the 4 delta x. Now the limits of integration goes from here to here. This is just x equals 2. X equals 2. 2 is the upper bound, and the other is the intersection between the line y equals minus 1 and square x minus 1. So would be minus 1 equals x squared minus 1, 0 equals x squared, so it goes from 0 to 2. And the last one is the region enclosed by y equals sin x, the x-axis, and to the left of x equals pi over 2. So this is sin x, the x-axis is this, and the region to the left of x equals pi over 2. So it will be this region, and we will rotate this about x equals pi over 2. So we will have this solid. This will be our solid. So now the discs will look something like this. The radius, that's correct? Yeah, that's correct. The radius of this goes from, the distance from x equals pi over 2 and the graph. So if we subtract all this distance, that is x equals pi over 2, and to that we subtract this small distance, that is the x value of the function, we will have all this distance. So we have x equals pi over 2, so the radius would be pi over 2 minus the x value of the function. So let me put sin x in terms of x, so it would be sine to the negative 1 of y. This is our radius. So if we square this and multiply it by pi, we have the area. If we multiply this times delta dx, we have the volume of one disc. And now we put the defined integral from, we are going from here, that is the x-axis, this is our lower bound, to here. This is the intersection between the line x equals pi over 2 and the graph of y equals sine x. So we are going from 0 to here. This is when does y equals sine x is equal to when what's the value of y when x is equal to pi over 2. So y is equal to the sine of pi over 2. So this is just 1. So we're going from 0 to 1 of the integral of pi over 2 minus sine minus arc sine or sine to the minus 1 of y, all this squared times pi dx. So now you know how to express, because the evaluation of the integral is easy. So now you know how to express the volume of a solid generated by a region that is rotated around or about a line that is not the x-axis or the y-axis.